Today we're going to talk about energy. Now, energy is the first module of the AQA GCSE Physics, and that is where we're going to start. If you asked a physicist what energy was, the very first thing that they might do is pause for a significant second. They'd have trouble telling you. And it's not necessarily due to some kind of lack of understanding, but it's a lack of being able to explain something that is very, very complicated in simple terms. You see, energy is kind of like the animal kingdom. There are different types of energy, and they are each very different from each other. So creating some kind of overarching explanation for all of it, description, characterization, is one of the challenges that the physicist will face. But what actually is energy? Well, energy is a quantity that we can measure. Energy carries the unit, the joule. Energy is the family name of a whole range of things. It can be measured with a joule meter in certain circumstances. The unit is the joule, abbreviated as a J. 5 joules is significantly less than 10 joules, just like that. And it works like any other quantity that we might have in physics. Albert Einstein, nearly 100 years ago, came to a startling conclusion about energy. What he found was that energy was far more involved than anybody had thought. He thought that all of the energy present in the universe and all of the matter in the universe, all of the hard stuff, you, me, the walls, the earth, the sun, were actually two different facets of the same thing. The implications of his work are still being investigated now. You may have heard of his equation that connects energy and matter together. Perhaps the most famous equation in physics, E equals mc squared, that energy was equal to matter times by the speed of light squared. Now, we're not going to get as far as that in a GCSE course. We're going to cover the fundamentals of energy first. And the first thing is looking at various different types of energy. Energy, fundamentally, is something that can cause change in the universe. From common experience, if you don't have enough energy, then you can't climb the stairs. You can't change your position relative to the Earth's gravitational field by going upwards. If you haven't got the energy, you can't run across the rugby pitch. You can't increase your kinetic energy to go faster. You haven't got the energy in a battery, then you cannot power an electrical circuit. Not having energy means you can't change things. Having energy means that the universe can experience time-dependent change. Movement is connected to energy. If you move, you have energy. If you move faster, you have more energy. This type of movement energy is called kinetic energy. Kinetic energy is connected to two things: how fast you're moving, your velocity, and also how much mass you have. If you have more mass, then you will carry more energy when you move. You wouldn't want to get in the way of a rhino running at full speed, but you wouldn't perhaps mind getting in the way of a mosquito going at the same speed. It's evident that the more mass you have, the more kinetic energy that you might have. Energy can sometimes accumulate. We can build it up in a certain type. Now, when this occurs, we describe that as an energy store. And we use that word store in the same way that we might use it in common usage. A store cupboard, we're storing something up. The amount of energy is increased in the store. the types of energy we're talking about now are all energy stores. We shall make a start by describing the energy stores as so. The first, kinetic energy. Kinetic energy is given the symbol E subscript K. Energy kinetic. Now that's not important now, but it will be important when we look at the formula for kinetic energy. Climbing the stairs. Climbing the stairs takes energy. I'm actually having to do some work against gravity to get to the top of the stairwell. This is an example of storing energy in a different kind. This is an example of gravitational potential energy. You see, even here, high up on the roof of science, we have had to invest a whole load of energy to get up here. So how is this an energy store? Well, if you think about it, stored within me now, there's a great amount of potential energy that could be unlocked. Down there, the drop, it would be unlocked. Anything dropped off this edge would suddenly find that it has this vast store of energy in the form of gravitational potential energy. A water balloon chucked down there would speed up, and where does it get that kinetic energy from? It is from the gravitational potential energy stored within it in bringing it up to this height in the first place. So we can add gravitational potential energy to our list of energy stores. Now, gravitational potential energy is given the symbol E for energy, subscript P for potential. E subscript P. Again, it's going to be important when we get to the formula. The next energy store I want to draw to your attention is that can be found in a spring. This spring here, if I extend it further and then release, it snaps back again. By extending it, I was storing energy within it. Elastic potential energy. Now that has a name that is very similar to gravitational potential energy. And indeed it is similar. I store energy up in a spring. On release, it gives me that energy back again. Therefore, it is an energy store. Now, any material that resists compression, be it spring, or rubber, or elastic, or any material that resists being stretched, is going to be a store of elastic potential energy. So I was writing on my board, elastic potential energy. And this has the symbol E subscript E, lowercase e. That's much better. Here I have another store of energy. You see, this is no ordinary cup of tea. In fact, it's not even a cup of tea. But I'm using it to demonstrate to you something that is hot. See, anything that is warm or hotter than the environment around has a store of thermal energy, type of energy that you find in hot things. We'll add that to the board, though for now we're not going to give it a symbol. Thermal energy. These are the main types of energy store, But there are one or two other kinds of energy store that you should at least have some familiarity with. And these are magnets. And magnets actually can store some energy. You see, in taking these magnets, if I bring this magnet close to this magnet, there is stored magnetic energy in here that would result in this suddenly gaining some kinetic energy and sliding along and connecting to that magnet. Now this energy store is not one of the most obvious ones. Another subtle energy store is electrostatic energy. Here I have a balloon. Okay. This balloon is made out of charges, protons and electrons that form part of the atoms of the rubber of the balloon. Now normally in an insulator such as this, they're all fixed in position, but I can transfer some extra negative charges from my hair onto the balloon. And with any luck, I can demonstrate how there is a little bit of energy now stored within this balloon. So, excuse me, Einstein, just bring this close and yes, I love it when a plan comes together. So there we have it, almost complete. But there is one more energy store, and one that is very important to all of us. Nuclear energy. You see, nuclear energy might not be obvious, and when you think of nuclear, you might think of something like this, nuclear waste. Some friends from Chernobyl sent this to me. It's a bit leaky though. But I actually mean the kind of nuclear energy that is actually providing the Earth with most of the energy that we receive. I'm talking about the energy that is being unlocked within the Sun. Inside the Sun, thermonuclear reactions are taking place, technically nuclear fusion reactions, creating the light and the heat that sustains life on Earth. Of course I'm going to refer to this, and radiation is going to be a topic that we covered later on in this course. So to complete the set, we're going to add nuclear energy to our energy stores. And finally, the final kind of energy store that we wish to talk about is chemical energy. It's a good apple, that. In fact, there's chemical energy in all of the food that we eat. We unlock the energy stored in the chemical bonds every time we eat something. Now that chemical energy is in my body. But there are other sources of chemical energy as well. In a battery, for example, stored up within the chemicals of the battery, there is chemical energy. In fact, anything that is a fuel, anything that you might burn, be it petrol or wood, is also a store of chemical energy. And so we'll add that to our list, and then this is the final one. You will need to know all of these energy stores, to be able to describe an example of each one. You will also need to be able to talk about how energy could go from one store to another store. How an object lifted up high might have its energy transformed into kinetic energy as it falls towards the ground. Our next section is on energy transfers.